Good afternoon, friends. I am Dr. Shanmukh Kuchwal, Academic Coordinator, Suresh Angri Education Foundations, Angri College of Commerce and Science, Sangha Road, Belgavi. Today, in this session, we will continue last topic, that is a differentiation. So today's topic name is differentiation part 3. Directly, we will go for an example number 13. Here y is a given, y equal to, it is tan inverse sin x divided by 1 plus cos x. Then we have to find the value of dy by dx. So here we use half angle formula. Using that we will simplify. Okay, so here y equal to tan inverse using a half angle formula, the numerator sin x is written as 2 sin x by 2 cos x by 2, x divided by 2, whole divided by 1 plus cos x. This can be written as 2 cos square x by 2. So here we can cancel 2 and 2 and 1 cos and 1 cos get cancels. So we get y equal to tan inverse, it is sin divided by cos, that is tan x divided by 2. Now tan and tan and tan inverse get cancels. We get y equal to x by 2. So if you differentiate this one, y differentiation is dy by dx. So differentiation of x is 1, we get 1 divided by 2. Therefore 1 by 2 is a right answer. So B is a right answer. So next example, it is given that u equal to, it is a sine inverse of 2x divided by 1 plus x square, and v equal to tan inverse 2x divided by 1 minus x square. So using a formula, it is a standard formula, sine inverse of 2x divided by 1 plus x square. This can be written as 2 tan inverse x. Similarly, another function, so that is v equal to tan inverse 2x divided by 1 minus x square. This can be written as, so standard formula it is 2 tan inverse x. So you have studied this concept in inverse trigonometric functions. Now we observe that RHS part of both the equations are same, therefore we can write u equal to v. LHS are same. So if we differentiate, u is a dependent variable and we have to take v as an independent variable. So differentiation of a u is du divided by dv, and v is an independent variable, differentiation is 1. So du divided by dv, it is a 1. Therefore option C is a right answer. Okay, we'll move to a next example. So it is given that y equal to sine inverse of cos x. So we make use of a inverse trigonometric function. We have to convert cos in terms of a sine function. So that can be written as using allied angle formulas, that is a sine inverse. Cos x is written as sine of, it is a pi by 2 minus x. So now sine and sine inverse get cancels, y equal to pi by 2 minus x. Okay, so further this is a y value, we need to find differentiation of a y with respect to x. So dy divided by dx equal to differentiation of a pi by 2, it is a constant, differentiation is 0 minus as it is x differentiation is 1. So 0 minus 1, answer is minus 1. Therefore C is a right answer. So we move to our next example. So example number 16. So here we have a function y equal to log of log x. Then we have to find dy. Excuse me. We have to find dy by dx. So here differentiating y, we get a dy by dx equal to. So it is a composite function differentiation. Log is a outer function, log of a log x is an inner function. So differentiation of this is log of a function is 1 by function log of log x. Okay, so further we have to find log, we have to treat as a outer function, log x is an inner function here, right? So we get a differentiation as 1 by log x. So further log x differentiation is 1 by x. So once again you can go through it. Log of log x. Log is a outer function. Log of a function is 1 by function. See, log means 1 upon function log x. So log x I have written. Log x differentiation is 1 by x. So we can see here that x and then log x and log x. It is there in a option C. Therefore C is a right answer. So further next example. So here it is a given that y equal to under the square root of sin x plus sin x up to infinite many number of terms. Then we have to find dy by dx. So here we observe that root sin x plus root sin x, it is repeating, so we can replace this by a y. So it is the same expression. So square root, in order to find a very simple way finding a differentiation means we have to avoid square root. So square on both the side, so we get y square equal to sin x plus y. So now we differentiate. So y square differentiation is 2y dy divided by dx. Sin x differentiation is cos x and y differentiation is dy by dx. Now we collect dy by dx towards the LHS side. So dy by dx we take a common, then we left with 2y minus 1 equal to cos x. So further in the next step we can write a solution for a dy by dx as cos x divided by 2y minus 1. That is option C is the right answer. So next example, example number 21. Sin y equal to x times sin a plus y. We have to find dy by dx. If you differentiate y with respect to x, then simplification it takes too many steps here. So instead of this we differentiate x with respect to y. X with respect to y, right? So first I write a solution for a x. X equal to, it is a sin y divided by sin of a plus y. It is a plus y. So differentiation of a x is with respect to y, it is dx divided by dy. Similarly, variable y is present in a numerator as well as a denominator, so we have to use a quotient rule. So denominator as it is sin a plus y, and numerator differentiation it is a cos y minus numerator as it is sin y, and denominator derivation it is a cos of a plus y, and whole divided by, it is a denominator square, that is sine square a plus y. Okay, so further the numerator, it is of the form sin a cos b minus cos a sin b. This can be written as sin a plus b. A is a plus y, b is y. That is, here it is a minus sign, here it is a minus. So sin a cos b minus cos a sin b is sin a minus b. We have written divided by, it is a sin square a plus y. Here we observe that 1y get cancels, plus y and minus y get cancels. So we get this as dx divided by dy equal to, it is a sin a divided by sin square a plus y. So further it is a dx upon dy. We need to take a reciprocal of this. So it is a dy by dx equal to reciprocal of this, it is sin square a plus y divided by sin a. Therefore option D is a right answer. Yes. Now next example, x, it is a parametric function in terms of a variable t. Similarly, y is a parametric function in terms of a t, and we need to find dy by dx. So here it is, we observe that 1 plus x square. So we take the method of a substitution and take the value of a t equal to tan theta. The value of t equal to tan theta. So 1 plus t square, 1 plus x square means that corresponding to your x, we have to take it as a tan theta. So if you substitute tan theta, t equal to tan theta, we get a 1 minus tan square theta divided by 1 plus tan square theta. So that is cos 2 theta. Further, y equal to, take t equal to tan theta, 2 tan theta divided by 1 plus tan square theta. So it is sin 2 theta. These are all important formula you are studied in PUC first year trigonometry, multiple angle, half angle formula. There you came across such type of a formula. Now we will find a dy by dx. So dy by dx equal to, it is dy divided by d theta divided by dx divided by d theta. So we differentiate y with respect to theta. So sine differentiation is cos 2 theta and 2 theta differentiation is 2 it is. Similarly, dx upon d theta, it is a cos differentiation is minus sine 2 theta. So 2 theta differentiation is 2. Now 2 and 2 get cancels. Now answers are not in terms of a cos and sine or any trigonometric function. It is in terms of a x and y. Now I take cos 2 theta as a x and a minus as it is sine 2 theta as a y. Therefore option A, it is a minus x by y. Therefore A is a right answer. Excuse me. Next example, if x equal to 2 cos t plus cos 2t and the y value is 2 sin t minus sin 2t, then dy upon dx we have to calculate. Further, the value of a t, we have to take it as a pi by 4 and we have to find a solution for this. So we write this as dy by dx equal to, so Why it is in a numerator? So first we find a differentiation for this. 2 cos t minus 2 cos 2t. This is dy upon dt. Similarly, dx upon dt we calculate. It is minus 2 sin t minus 2 sin 2t. So further, the value of a t we take it as pi by 4. Value of a t we take it as a pi by 4. So we can write dy upon dx equal to it is a 2 times cos pi by 4. It is a 45 degree 1 by root 1 by root 2. Next minus it is 2 into, here it is 2 into pi by 4, 1 to get cancels, cos 90 degree, it is a 0. Whole divided by, I take the value of a t equal to pi by 4, I get minus 2, 45 degrees 1 by root 2. Further, here it is a sine 90 degree we get it, 1 into minus 2, minus 2. So further, numerator simplification we get a root 2, denominator simplification, yes, it is a, we can take a minus common, so we get a root 2 plus 2. So further, in a numerator I take minus root 2 as a common and we get a 1, and denominator we get a root 2 as a common, 1 plus root 2, and here root 2 get cancels, it is minus 1 divided by 1 plus root 2. So further, denominator we have to rationalize. So this is not among any one of the option, so we have to rationalize it. Minus 1 divided by 1 plus root 2, and we have to multiply by its conjugate, that is 1 minus root 2 divided by 1 minus root 2. So numerator simplification is minus 1 minus root 2. Denominator simplification is, it is of the form a plus b into a minus b. Simplification is a square minus b square, so it is 1 minus 2. So simplification for this is minus 1. Minus minus get cancels, we get answer as 1 minus root 2. Yes, so answer is 1 minus root 2. That is option B is a right answer. So further, example number 24, the differential of e raised to x cube with respect to log x is, that is, so it is a parametric differentiation. So we take one function as a u equal to e raised to x cube, v equal to, it is a log x. So further we find differentiation for this, that is du divided by dv equal to, it is du differentiation of a u with respect to x divided by differentiation of a v with respect to x it is. So we get this as 3x square e raised to x cube whole divided by log x differentiation is 1 by x. So 1 upon x we have to take a reciprocal of this. So 3x square e raised to x cube into x it is. So we can write this as 3 times x square into x cube e raised to x cube. So option C is a right answer. Further, example number 91, we have to find d upon dx, that is differentiation of a cos x degrees. It is in terms of a degrees, we have to convert in terms of a radian measure. So conversion is just we have to multiply by pi divided by 180. So conversion is y equal to cos of, it is x pi divided by 180 degree. Further we find a differentiation. Differentiation of a y is dy by dx. So differentiation of a cos is minus sine, it is x pi divided by 180 degree. Now inner function differentiation, so x differentiation is 1 and constant as it is. So option B is minus pi by 180 sine x degrees here. So we can convert into a degrees that once again. So B is a right answer. B is a right answer. Now next example, tan y is 2t 1 minus t square, sin x is 2t divided by 1 plus t square. We have studied inverse trigonometric function. Tan it is in LHS. If you transport in a RHS, it will become an inverse. So I can write this as y equal to, it is a tan inverse 2t divided by 1 minus t square. Similarly, sine we have to transport to a RHS, it will become an inverse, x equal to sine inverse 2t divided by 1 plus t square. 1 plus t square like this. So y equal to, so it is a one of a standard formula, tan inverse 2t divided by 1 minus t square, it is a 2 tan t formula it is. And further here it is, this is also standard expression, it is a 2 tan t, right? So we observe that RHS are same, LHS we can equate, so we get y equal to x. Further we find differentiation of a y with respect to x, so differentiation of a y is dy by dx and x differentiation is 1. So option D is a right answer. Option D is right answer. So further next example, d upon dx of cos inverse x plus sine inverse root of 1 minus x square is equal to, first option is 0, second is 1, third is 2 divided by under the square root of 1 minus x square, fourth option is minus 2 divided by square root of 1 minus x square it is. So we have to verify. So I make use of a inverse trigonometric function relation, that is sine inverse, there is one formula, sine inverse of root of 1 minus x square is cos inverse x, cos inverse x. So we can write this as d upon dx of cos inverse x as it is. So using this formula we can replace sine inverse of root of 1 minus x square as it is a cos inverse x. So further d by dx as it is, cos inverse x plus cos inverse x is 2 cos inverse x. So differentiation of this is, so 2 as it is, cos inverse x differentiation is minus 1 divided by under the square root of 1 minus x square. Therefore option D is a right answer. So we'll move to a next example, the derivative of sine inverse x with respect to cos inverse root of 1 minus x square. Here we take u equal to sine inverse x and v equal to cos inverse root of 1 minus x square. So using earlier relation, this is satisfied with reverse order also. So cos inverse of root of 1 minus x square can be written as sine inverse x. Okay, so I can write v equal to sine inverse x. So and u is sine inverse x only it is. Okay, further RHS are same, LHS we have to equate u equal to v, and differentiation of a u with respect to v is, it is a du divided by dv equal to v differentiation 1. So C is a right answer. So next example, it is a y equal to cot inverse of, it is tan pi by 2 minus x. So using trigonometric relation we can write this as a cot x. So further cot and cot inverse get cancels, so we get y equal to x. So differentiation of a y is dy divided by dx equal to, it is a x differentiation is 1. Therefore option B is a right answer. Okay, we'll move to a last example. It is a y equal to 2 raised to 2 raised to x. See, remember, if it is variable raised to variable, we have to take log on both the side, or else if it is variable is a power is a variable, then we have to take a log on both the side. So taking a log on both the side, we get log y equal to log of 2 raised to 2 raised to x. So use a property of a logarithm. This is log y as it is, and see, we can write 2 raised to x times log 2. Okay, further we have to differentiate this one, differentiating. So log y differentiation is 1 by y, and y differentiation is dy by dx, because y is a dependent variable. Then here we observe that log 2, it is a constant multiplied by variable, so constant, keep it outside. A raised to x form, it is 2 raised to x, it is in the form a raised to x. A raised to x differentiation is a raised to x into log a. So 2 raised to x into log a value is 2, log 2. Then we can write this as dy by dx equal to y with transport, it shift in a numerator, 2 raised to x, then log 2 whole square. So D is a right answer. D is a right answer. So this completes differentiation. In the next session we discuss the application of a differentiation. So any doubt you have, then kindly bring to the notice of us. We have a WhatsApp group, admin's numbers will be there, you can contact and we'll solve those problems. Once again, good afternoon everyone. Thank you very much.